benefits of maritime model-based systems engineering are currently not being leveraged at all. It appears to be quite a challenge to convert the results of model-based systems engineering into a successful ship.
Converting a ship into formulas is just the beginning of the complexity. Many maritime engineers get stranded in a swamp of results.
In this video, we take you through the world of model-based systems engineering. First, we explain what it is. Second, we'll explain how model-based systems engineering is currently being used in the maritime industry. And finally, we'll explain how you can successfully use this topic.
First, what is model-based systems engineering? To understand its benefits, we first need to look at a ship. A ship is in fact a very complex object. Really everything has a relationship with each other. And that is why it takes 3 to 4 weeks to manually calculate a ship's concept design. The engineers really have to calculate everything in relation to each other.
That's why more and more maritime companies are starting with model-based systems engineering. With this, you express the entire design of a ship in a mathematical algorithm.
The advantage of this is that in case of changes in ship requirements, the calculations can be redone much faster and the outcome is more reliable. However, there also is a disadvantage to developing a ship design with model-based systems engineering. Based on the requirements, an engineer easily gets 10 to 20 viable results. Those are the possible configurations for the ship.
So, which ship configuration is the right choice? After all, they all meet the requirements. From that point on, many maritime companies go further and further into the result swamp.
Let me give you an example to explain this. Imagine that as a maritime engineer you want to design a dredger. You enter all the requirements into the model-based systems engineering model and you then get 20 ship configurations as a result. So which one is the best? How do you evaluate that?
What often happens next is dramatic for the outcome.
Indeed, one determines, for example, that the parameter cheapest per cubic meter of dredging must be leading in the final design. But you cannot design a successful ship based on one single parameter, because there are other aspects just as important for a dredger. The conditions in which it has to work, the sustainability parameters, the capex, the opex, and so on and so forth. So why are these aspects not all included anyway?
Well, the explanation is simple. One evaluation parameter is already complex enough for your model-based systems engineering design, let alone 10 to 20 parameters. No matter how smart the human brain is, unleashing 20 parameters on a highly complex design is something no one can do.
No one can indeed, but Shipbuilder software can. We have developed a powerful tool with which you can evaluate the model-based systems engineering results based on all your parameters in order to identify the ideal design.
Imagine the engineers are presented with a top 3 of designs. Our software also indicates how the top 3 came about and what the advantages of each top 3 results has. And that's not all, because behind this tool an artificial intelligence engine is running. The results of the designs become more and more refined.
And so, the engineer no longer has to do the complex evaluations on his own. He or she can instead focus on innovations. People are much better at that than software. A win-win, because the innovations are coming faster and faster, and the designs are getting better and better. We are getting close to perfection.
Thank you very much for watching this video. Would you like more information about model-based systems engineering and how it can help you? Please feel free to contact us. And by the way, did you know that we also provide training to get started with model-based systems engineering? Oh yeah, and don't forget to follow our channel and give this video a huge like.